We'll now begin section 1.3, where we will discuss polynomials. Polynomials are a special class of algebraic expressions. Each of the terms in a polynomial consists of a number multiplied by a variable like x. And sometimes it's not multiplied by anything at all. And it's going to be raised to a positive integer exponent. We'll begin by looking at some examples for polynomials. Our first example is 14x to the 6, which is a monomial because it only has one term. That one term is in terms of x, so x is our variable. The coefficient of the term is 14, and when we talk about a coefficient, we are talking about the number that sits in front of the x. And the degree of the term is 6, because that is our exponent. And that's also the degree of the polynomial. Recall that the degree of the polynomial will be equal to the highest exponent. For part B, we have negative 3 x to the 4th, y to the 2nd, plus 5.4 x to the 3rd, y to the 4th. This is called a binomial because we have two terms in the two variables x and y. The degree of the first term is 6 because we have an x to the 4th and a y to the 2nd, so the sum of our exponents will be 6. And the degree of the second term is 7 because we have a third power and a fourth power. Summing together makes 7. So the degree of the entire polynomial is equal to 7. Remember that your degree is equal to your highest exponent. So our degree would be 7 because that is the exponent summed on this second term. The coefficient of the first term is negative 3. That's the number. And the coefficient of the second term is 5.4. All right, this is kind of a special case. We have the single number 5. That can be considered a polynomial. In particular, it's a monomial of degree 0. So why do we say that this one has degree 0? And the answer to that is because we can write it as a power of x like this. We can say it's 5 times x to the 0 power. And we know that anything to the 0 power is equal to 1. So this is really like saying 5 times 1. All right, so the degree would be 0. That's going to be the highest exponent. The coefficient would be 5 because that's the number that sits in front of the x. All right, our next example says that we have 2/3 x to the 3rd, y to the 5th, minus z, plus y to the 10th, plus 3. So this one has 4 terms, and so we just refer to it as a polynomial. It does have 3 variables because it has x, y, and z. This 3 is referred to as a constant term because it does not have an x to go with it or a variable to go with it. The degree of the polynomial is 10. That's our highest exponent here. We have a 10. Over here we have a sum of 8. But the degree would be 10. And the degree of the individual terms, we would have an 8 on this first term. We have a 1 on this term, z to the first. We have a 10 on the y term. And we have a 0 on the 3, because remember that this can be written as 3 times x to the 0 power. And the coefficients would be 2/3, would be negative 1, positive 1, and positive 3. Okay, let's look at a couple that are not polynomial. This first one, x to the 3rd plus 2x plus 7x to the negative 1 is not a polynomial because of this negative 1. We said in our original definition that it had to be raised to a positive integer exponent. So negative 1 is not going to be positive. So that first one is not a polynomial. Our second one, the square root of x. Remember, the square root of x can be written as x to the 1/2 power. It's the same thing as x to the 1/2 power. And so again, polynomials have to have positive integer exponents. This doesn't have a integer exponent, it has a fraction. So not a polynomial on that as well. All right, so our formal definition for a polynomial of a single variable looks like this. It says a polynomial in the variable x of degree n can be written in the form, and all of these a's are going to be numbers. So a sub n minus 1, a sub 1, a sub 0, those are all going to be numbers. And the n's will be positive integers. Those are your exponents. So we have a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus, and there's some terms in between here. Our next to last term will be a sub 1 times x plus a sub 0. And this is putting the polynomial in descending order because we're going from our highest power to our lowest, and the leading coefficient of the polynomial is going to be a sub n. So that's going to be your first coefficient on that x to the n term. Now we'll look at just doing some basic operations on the polynomials first. We're going to start with addition and subtraction. So we have as our first problem in parentheses 2x to the third y minus 3y plus z squared times x. That's our first polynomial. And we're adding it to, and then we have this in a second set of parentheses, 3y plus z squared minus 3x z squared plus 4. And so what we're going to need to look for here is going to be anything that is common that can be combined. So the first thing I'm going to do is I'm going to, since this is addition, I really don't need these parentheses. So I'm going to go ahead and sort of rewrite our problem here and drop the parentheses. And then we will look at what kind of combining we can do on our terms. So when we do this, the first thing that I notice is that I have a negative 3y and I have a positive 3y. And those two terms are going to cancel out. All right, so let's look and see what else we have. We also have a z squared x right here, and we have a z squared x with a negative 3 coefficient right there. Now notice that the terms are in different order. This is z squared x and this is negative 3x z squared, but it doesn't matter because it's multiplication. It doesn't really matter what order. Those are considered like terms. They both have an x, they both have a z squared. So you want to keep in mind that there's a positive 1 sitting in front of this first one. So we really have a positive 1 and a negative 3 combining to make a negative 2xz squared. And that's going to take care of those two terms. All right, I don't see anything else that I can really combine, and so I'm just going to rewrite the rest of it. I'm going to write down the 2x cubed y. That's going to take care of that one. I'm going to tack on a plus z squared and a plus 4. And so this will be my final answer. 2x to the third y minus 2xz squared plus z squared plus 4. And notice that I do have it written in descending order in terms of the degrees. The degree of this first term is going to be 4 because we have a 3 and a 1 exponent. Then the degree of the second term will be 3. We have a 2 and a 1. We have a degree of 2 and a degree of 0. All right, so let's look at part B. We'll do kind of the same thing. This is subtraction, so the only thing that I need to concern myself with here is that I need to be sure that when I remove my parentheses that I change my signs in that second set of parentheses. So my first parenthesis looks like 4ab cubed minus b cubed times c. And then on the second parenthesis it's minus, and in parentheses we have 4 minus b to the third c. So I'm going to go ahead and distribute that negative through that parenthesis. So it's going to become minus 4 plus b cubed c. And so again, as I look at my terms, in terms of combining like terms, I notice that I have this term and this term. So I have a negative b cubed c and a positive b cubed c. So those are going to cancel out. The other two terms do not combine because they're not like terms. So I have 4ab to the third minus 4 as my final answer. Okay, so we've done some addition and subtraction. We can also do some multiplication. Multiplication for polynomials essentially means that you are going to distribute. All right, so our first problem says that we have 2x squared y minus z to the third. That's our first polynomial, and now we're going to multiply that times 4 plus 3z minus 3xy. And so what we're going to do is we're going to take this 2x squared y and we're going to multiply it by all three of these terms in the second polynomial. So 2x squared y times 4 is going to give me 8x squared y. 2x squared y times 3z is going to give me 6x squared yz. And 2x squared y times negative 3xy is going to give me a negative 6x to the third. We have a x squared and an x to the first. And y squared. We have a y times y, which would make y squared. Okay, and then we're going to have the same sort of operations on the second term. So this negative z cubed, we're going to multiply by all three terms in the second polynomial. So negative z cubed times 4, we have minus 4z to the third. Negative z to the third plus 3z, or multiplied by 3z, we're going to have negative 3z to the fourth. We have z to the first, z to the third. And then finally we have a negative z cubed times a negative 3xy. So that's going to be a positive 3xy z to the third. All right, and then again, we're going to look and see if anything can be combined. And let's see if anything can. And I am not seeing anything that can be combined together. And so I think that we are actually done with this problem. All right, so we're going to leave our final answer as this. All right, and then let's look at part B. Part B says that we have 3ab minus a squared, and we're multiplying that times ab plus a squared. Now, we have the FOIL method that we want to review here to be sure that we sort of remember how we're going to multiply these two polynomials together. We'll write it down over here. Remember that the f stands for the first terms, so you're going to multiply these first two terms together. So 3ab times ab is going to give you 3a squared b squared. The O stands for outside, so you're going to multiply the 3ab times the a squared, gives you positive 3a to the third b. The I stands for inside, so you'll be multiplying these two together, negative a squared and ab, making a negative a cubed b. And L stands for last, so you'll multiply the negative a squared times the positive a squared, giving you negative a to the fourth. Typically, when you're doing the FOIL method, your middle terms will combine. So we have a 3a cubed b minus an a cubed b, which is going to give you a 2a cubed b. And the rest of it's going to stay as it is. And so our final answer is going to look like 3a squared b squared plus 2a cubed b minus a to the fourth. All right, and the last thing that we're going to do on this presentation is we're going to talk just real briefly about a couple of special product formulas. Remember that you have what we call the difference of two squares that is shown on this first one. So a squared minus b squared is going to factor into a minus b, a plus b. If you are multiplying out a plus b squared, you want to always remember that this is the same as a plus b times a plus b. And then you can do the FOIL method to get a squared plus 2ab plus b squared. If your problem had been a minus b squared, remember that that's a minus b times a minus b. And again, you could do FOIL method to do a squared minus 2ab plus b squared. So these are really, number 2 and number 3 are not really things that you need to memorize. You just need to know that if it's written as a plus b squared, that it actually means you're multiplying it times itself and you're using the FOIL method. And the same approach for number 3.